Good morning. My name's Jane Barrett and I'm the Secretary General of the International Federation on Age. The IFA is delighted to continue our post-conference series of webinars with a presentation from Dr. Yakov Stern entitled Cognitive Reserve Promoting Healthy Cognitive Aging. But let me tell you a little bit about Dr. Stern. Yakov is really the father of cognitive reserve. There is no doubt in my mind that this is going to be not only stimulating and informative, but you're really going to have a much deeper understanding of the impact of his research and those of his colleagues in the context of healthy aging. Dr. Stern directs the Cognitive Neuroscience Division of the Department of Neurology. He's the Chief Cognitive Neuroscience Division, Department of Neurology, at the Taube Institute for the Research on Alzheimer's Disease and the Aging Brain at Columbia University College of Physicians and Surgeons. But, most importantly for me, Yakov has been able to take incredibly complex concepts and research and applications and make sense of them to the everyday person. And each of us that are on this webinar today, I know will actually gain a sense of the importance of his work. When asked about his interest in cognitive reserve, Yakov said, I'm interested in understanding why some individuals show more cognitive deficit than others, given the same degree of brain pathology. And when in talking about cognitive intervention in normal aging, he said, we are exploring potential non-pharmacological interventions that might improve cognition or cognitive functional outcomes in normal aging. And when we're in a world where there is such almost panic about, the incidence of Alzheimer's disease now and in the future, this is incredibly important work. So, Yakov, we really welcome you and thank you for being the presenter on this webinar today. I hand the controls over to you, Yakov.
Okay, thank you very much for that very generous introduction. And it's really my pleasure to talk with you this morning, at least here in New York this morning, on the concept of cognitive reserve. As was said, it's something that's a topic that's near and dear and that I've been thinking about for a long time. But before we get to cognitive reserve, I just wanted to talk for a minute about cognitive aging and Alzheimer's disease. This is an interesting set of graphs. This is a study by Michaela Gallagher, a set of studies looking at rats. They put them in this pool of water that's milky and they have to find a platform to stand on that they cannot see. And what you can see here is that this is the time it takes for them to find a platform, and as they practice, they get better. And you see that the younger rats always do it faster than the older. They learn it much more quickly. Then they have this other measure is they take, this is sort of diabolical. They take away the platform and they look to see how much the animals hang around where the platform should be. And the younger people do that better than the older people. So the point here is that even in rats, there's a memory decline in normal aging. Rats don't have Alzheimer's disease, it's just an aging process. But here I think is sort of a key thing to look at. This is the same bar graph where the older animals are doing more poorly, hires more poorly than the young, but now broken up by individual rats. And you can see that the young rats all cluster down here, but look at this, the older rats, some are doing very poorly, but a bunch are doing just as well as the young rats. And it's this heterogeneity and diversity in the cognitive aging that's really struck a lot of us. Why do some people do a lot better? Here it's rats, but why do some people or rats do a lot better than others in the process of cognitive aging? Now, when it comes to humans, there's been a lot of studies of cognitive aging. This is from Timothy Salthouse, who has these very large studies where he tests people from age 20 through 80. And it's sort of a sad story when you look at it this way. There's certain functions that are maintained with aging or perhaps even improved, like vocabulary, knowledge of facts, and knowledge of definitions. But other cognitive functions like memory, processing speed, reasoning tend to decline with aging. And this is on the mean, that's really much the case. Now, what's behind that? So we've tried to look at various reasons for this kind of age-related cognitive change. And what we do is we sort of turn to the brain, so we can measure brain volume, how big the brain is, or parts of the brain. The cerebral cortex, how thick is it? And in both of these cases, on the average, there is a decline in brain volume and cortical thickness with normal aging, although you see there's, again, a lot of variability around this decline. Similarly, the white matter, those are the parts of the neuron that transmit the signal from one place to another, and they have this coding that allows them to do that successfully. That white matter integrity goes down, and people develop these changes that we can see on scans called white matter hyperintensities. So we use this to try to correlate these brain changes with the cognitive changes. Similarly, we have Alzheimer's disease. This is an old graph, but it's similar to what we see elsewhere. As you can see, the prevalence, the percentage of people with Alzheimer's disease increases significantly with aging. So the prevalence is quite low at age 60. By age 90, it's really quite high. It may be up to 30 to 50% of people might have Alzheimer's in some studies. What underlies Alzheimer's disease? Again, it's brain changes. The two things you've probably heard of are plaques and tangles. So this is a picture of a plaque. It's stained so you can see it. It's a kind of a protein in the brain. This is a picture of tangles, these gray, dark brown things here. They're actually inside neurons. And people with Alzheimer's disease have these plaques and tangles. And they're sort of two of the key brain changes that we feel are associated with developing Alzheimer's disease. What's really interesting is now we don't have to wait for autopsy to look into people's brains. We have these PET scans we can look at that actually can measure the presence of amyloid. So this is a very, very early study where here's 9 people with Alzheimer's disease, and where you see this bright red, that's where the scan is detecting scads of amyloid. Here's some healthy elderly people. They don't have that. What's very interesting is here's some cognitively normal elders that have an intermediate amount. They already have amyloid in their brain, even though they're cognitively normal. And why am I raising this? Because it turns out that people have amyloid in their brain for many, many years before they develop Alzheimer's disease. Some people have amyloid in their brain and die and never develop Alzheimer's disease. And so we're seeing this disjunction between the amount of pathology in the brain and people's presentation, their cognitive presentation. Similarly, now we can measure the tangles. And you know, here's people all with Alzheimer's disease, and where you see this bright red, they have all those tangles. Here's people with quite a bit of tangles, but 6 of them are cognitively normal, and 2 of them have Alzheimer's disease. So again, there's this disparity between the amount of pathology people have in their brain and whether or not they show a cognitive deficit. So this introduces this idea that there's this disjunction between the amount of brain changes, be the age-related brain changes that I was telling you about, like shrinkage of the brain or of the cortex, or damage to white matter, and the clinical outcome. And this is not just in aging and Alzheimer's disease. This is seen very often in any disease or condition that affects the brain. And this concept of reserve has been introduced to account for this disparity. So this reserve could explain this disjunction between the degree of brain damage and the clinical manifestation of this damage. And this is a concept that I'll try to develop further for you now. So this is a white paper. It's a consensus paper from what's called a PIA. It's an interest group from the Alzheimer's Association meetings, where we put together a work group to develop empirical definitions and conceptual frameworks for these concepts. And so I'm gonna be presenting those consensus diagnoses. And there's 3 concepts that I'm gonna discuss. One is brain reserve, brain maintenance, and then cognitive reserve. And I'll go through each of them in turn. Brain reserve is more about the brain itself, how big the brain is, how many synapses there are. brain maintenance is this concept that some people show less of these brain changes, these age-related brain changes than others. And then cognitive reserve, which I'll discuss further most of the time, is this adaptability of functional brain processes in the face of these brain changes. In other words, some people can cope with these brain changes better than others, and we've called that cognitive reserve. Okay, so let's start with brain reserve. The concept, I think the name was first used by Robert Katzman, who was sort of the dean of Alzheimer's disease research. He was doing a longitudinal study of aging in people in the Bronx, which is north of Manhattan. They followed elderly people and they got their brains at death. And he wrote a paper describing 10 women who were completely cognitively normal at death, but had a lot of amyloid plaques in their brain when they looked at their brains. And they wondered, how could that be? And what they speculated was these individuals had larger brains, which they did, larger than average. So they started with larger brains, more large neurons, and thus might be said to have a greater reserve. And they call that brain reserve. So the idea of brain reserve is sort of simple. If you have a larger brain, perhaps you can tolerate more damage to it before you begin to show a deficit. This neuropsychologist, Paul Satz, sort of codified this. He said, oh, there's something called brain reserve capacity, sort of how big the brain is, how many synapses and all of that. You can have one person with more brain reserve, brain capacity than another. And you could posit some point where once the brain capacity is depleted, the person starts to show functional impairment. So because this person has more brain reserve, he can tolerate the same lesion as this person without showing any damage. This person here has less brain reserve, gets the same amount of damage to the brain, and starts to show functional impairment. I call this a passive model because we're not talking about what the brain does in response. We're just saying, oh, once there's a certain amount of damage, the brain begins to show impairment. And that's this concept of brain reserve. Here's a very simple study done by Peter Schofield. He's a neurologist in Australia, but he was here when he was a postdoc here in New York. And he convinced the research assistants in a study we were doing in the Manhattan population to measure the circumference of all of our subjects. So here you have, these are black as females, white as males, smallest head circumference to largest, and here's the percent of people with Alzheimer's disease. And as you can see, as you move from larger head circumference to smaller, you have a higher and higher prevalence of Alzheimer's disease. So that's a very simplest example of brain reserve, where a bigger head is associated with more resistance to the disease. It seems very simplistic. I'm sure there's more to it. It's sort of a controversial concept. I'll get back to that later. But there are other conditions like traumatic head trauma, where a larger brain really is associated with better outcome. Now, the concept of brain maintenance is a newer one. The best paper introducing it only came out in 2012, so that's relatively recent. And what these authors posited was that individual differences in the manifestation of age-related brain changes and pathology allow some people to show little or no age-related cognitive decline. So it's the relative lack of brain changes in pathology that's the biggest contributor to the heterogeneity of cognitive aging. So they're basically saying for various reasons, some people do not show these age-related cognitive declines, or they don't develop pathology like Alzheimer's disease. They're maintaining their brain, and that's a very important way of accounting for why some people develop cognitive problems in aging and some don't. And they describe how various lifestyle factors can contribute to resisting the advent of pathology. And I'll talk about some of those lifestyle factors later, exercise, education, etc. And so this brain maintenance to me is a very important concept. People do show age-related cognitive changes. People do develop Alzheimer's disease. So the brain maintenance is sort of, to me, the opposite end of the cognitive reserve. Given a certain amount of brain maintenance, some people have better brain reserve, but then on the other side, as people develop problems, they need their cognitive reserve. And here's a brain maintenance story very simplistically. This is a paper by Michael Valenzuela, who's going to be in the IFA conference in Copenhagen that you'll hear about later. And what he did is he measured people's, the size of people's hippocampus. It's an area in the brain that's very important for memory. And he followed these people over time, and he measured something called LEQ. It's a life experience questionnaire, which is all of these cognitively stimulating activities that people had in their lifetime. And as you can see, he followed people for 3 years, and the people with higher LEQ showed less loss in hippocampal size than the people with lower LEQ. So that's a brain maintenance story. There's something about having cognitive stimulation from life that, at least in this example, protects people from age-related decline in the brain itself. So that's a brain maintenance story. Now, I contrast that with brain maintenance and especially brain reserve with cognitive reserve, which I call an active model of reserve. And why is that? So here's that graph I showed you before, another version of it. So again, we have two people with the same amount of brain reserve capacity. But now what I've drawn here is that this person can sustain a much more larger lesion to the brain than this one before she develops a cognitive deficit, before she has this functional impairment. Now, why could that be, that this person can tolerate a larger lesion than this one before they start to show a problem? It has to do with this part, the white part here, the brain itself actively attempting to cope with that brain change. And that's the concept of cognitive reserve, is this the brain actively attempting to cope with this brain damage and maintain function. Now, how did I get to this concept of cognitive reserve? It has to do, really the first time I started to think about it was quite a few years ago, where again, Dr. Katzman, who I had mentioned earlier, started to promote these findings that he was getting in China. And you would go, I went to these neurology meetings and got this buzz that there were fewer people with Alzheimer's disease in higher educated populations than lower educated populations. So the prevalence of Alzheimer's disease was lower in people with higher education. And I'm a neuropsychologist, and I said, well, wait a second, maybe they're just not testing these people well. Maybe people with higher education just do better on the tests that they use. And this is all just a diagnostic error. So I got very interested in it. And I said, well, the way to really start to look at this is by doing what's called an incidence study, where you take people who are not demented and you follow them to see who gets demented and who doesn't. So this is sort of a scheme built on a graph. This is a very old graph that Katzman had written, had printed about Alzheimer's. So there's various things that might initiate Alzheimer's pathology. It could be genes, it could be other life factors and other things that promote it. Let's say you get head trauma. And what happens is Alzheimer's disease, this pathology advances for a long, long time. For amyloid, it's at least 20 years before people start to show clinical symptoms. At some point, clinical symptoms appear. Eventually, they get bad enough that people are diagnosed, and then the disease progresses in severity. So the cognitive reserve concept is that there are things that can help determine when these clinical symptoms appear. So people with higher reserve can tolerate more pathology before the symptoms appear. People with less reserve can tolerate less pathology. So if you take people who are not demented and follow them over time, you might predict that the people with lower reserve will develop Alzheimer's disease sooner. And that's the study that we did. This is an old paper, 1994. We were following people in Washington Heights, which is in the northern part of Manhattan. And they were not demented at baseline. And in essence, here's sort of a summary of some of the things we found. Compared to the people with higher education, the people with lower education had double the risk of developing Alzheimer's disease during our follow-up period. Compared to the people with high occupational attainment, the people with lower occupational attainment, again, had double the risk of developing Alzheimer's disease. And how did we interpret that? Our interpretation was not that the education or occupation was preventing the pathology. We couldn't imagine that that could be the case. but more that these higher educational occupational attainment somehow allow people to cope with this pathology better. When we first started presenting these findings, it was very controversial because the idea that something like education could forestall the effects of a disease, a disease in the brain, seemed very strange to people. I think now we're much more accepting of this concept, but then it was quite controversial. I don't know how well you can see this slide, but I'll show you the point. This was a meta-analysis done in 2005. What they did here is they summarized all of the same kind of studies that I just showed you. People that, incident studies where they started with non-demented people and looked to see who got demented, looking at the effects of education, occupation, premorbid IQ, and leisure activities during late life. And anywhere where these bars don't cross the one line here, they found protective effects. So here's me. I was maybe the second person to have a study showing a protective effect, and there were 2 negative studies. So that's why people were very skeptical. But over the years, numerous studies have shown these protective effects. And what they did in this meta-analysis is they also sort of explained why some of the studies probably were not powered properly to see the protective effects. So anyway, my point is that this has been replicated over and over and over again. That there are certain life exposures like education, occupation, premorbid IQ, engaging in leisure activities that appear in these epidemiologic studies to be protective against disease pathology. What about normal aging? So here's a very early study. Jennifer Manley, who was my postdoc at the time, again from the North Manhattan study, we took cognitively normal people in our population. This is a memory test. It's called the selective reminding test. These are how many words they recall over the test. And what we were able to show is that people with higher literacy, which is a better measure of quality of education, showed less rapidity of decline than the people with lower education. We call that the slope. So they did better at baseline, but they also showed less decline over time than the people with lower literacy. Again, suggesting that there was something about literacy, which comes from education, that allowed people to cope with age-related changes better. Now, there have been, I'm just showing you this one slide, there's been numerous studies of this, and I have to say, in some studies they find this slope difference, other studies don't. Exactly why that is, I'm not clear, but we really can show in cognitive aging that some people can cope with those age-related changes better than others, and I think that's what explains this slide. We're focusing on normal aging, but you could ask, well, what about when people have Alzheimer's disease already? Do the people with higher reserve do better? And the results there are a little counterintuitive, so I have this conceptual slide to introduce it to you. Here we have people, on this axis we have Alzheimer's pathology getting worse and worse, and this is again a memory test score. And here's people with high reserve and low reserve. So if you followed what I've been saying so far, as pathology progresses, if what I'm saying is true, the people with lower reserve start to show cognitive changes earlier than the people with higher reserve. That's sort of why we might see differential incidence. Another assumption that we built in is sort of a common endpoint. The truth is that no matter how brilliant you are, if you get Alzheimer's disease, it's a devastating disease. It's not like, your higher education might forestall the effects, but it's a devastating disease. And it comes a point where people really are not functional. So if you posit those two things, you make a very interesting prediction that once you develop the disease, the progression is slower in the people with lower education and faster in the people with higher education. It's almost as if by the time they express the disease, the pathology is so bad that they sort of crump. And here's the first study that showed that from our group. These are people with Alzheimer's disease, again from the North Manhattan population, matched at baseline, and the people with higher education declined more rapidly than the people with low. And this has been replicated over and over and over again. Okay. So I wanted to figure out how to really nail down this concept that some people can cope with pathology better than others. And Here's a conceptual graph that just helps you understand how I was thinking about it. This is quite a few years ago. So again, we'll deal with Alzheimer's disease. So here's Alzheimer's pathology from very mild to severe. Here's clinical severity. In this case, people who are cognitively normal, have mild cognitive impairment, they're not dementia yet, mild Alzheimer's and severe. So if you follow what I've been saying, you might posit that when the pathology is mild, the people with low reserve might already be demented, and the people with higher reserve might still be able to maintain normal function. And that's why we see those differential incidence results. Even when the disease is more moderate and everybody has Alzheimer's disease, given a moderate amount of pathology, you might posit that the people with higher reserve have a milder disease severity than the people with low reserve. And that's sort of what reserve is giving you. It's even if you're progressing a little faster, the people with higher reserve are always doing a little better given the same pathology. Now imagine, just to make myself clear, imagine two people with mild Alzheimer's disease in terms of their cognition and their function. They're very comparable, one with low reserve and one with high. The prediction that you would make is that people with mild AD, the people with low reserve will have less pathology than the people with high reserve. So given the same amount of pathology, the people with low reserve given the same clinical severity, the people with low reserve should have less pathology than the people with high reserve. If you're not following that intuitively, they can cope with it better. So they have more pathology and they look the same as someone with low reserve that has less pathology. And I really wanted to figure out a way to prove that. At the time, what I really wanted is if you had autopsy studies, you could take two people that looked the same clinically during life, and you would posit that the people with higher education would have more plaques and tangles in their brain than the people with lower, but we did not have those data. But we had some imaging data. Here's a slide that I really love. It's one of the earliest papers that I published on cognitive reserve. What I have here are 20, 20, and 20 patients with Alzheimer's disease. They're all matched for clinical severity. And this is a graph of cerebral blood flow. It's a measure of what they now call neurodegeneration. It's a change that you can measure in blood flow as a function of Alzheimer's pathology. And if you focus on this spot here, you can see that it gets darker and darker and darker with increasing education, such that even though these three groups are matched for disease severity, these people with high education have more severe pathology. As if they're walking around with more pathology, even though they look the same. So controlling for disease severity, there's an inverse relationship between education and a functional imaging proxy for AD pathology. I was very excited. The reason I was so excited about this study is it puts everything that I'm telling you together in a single study. So if you think about cognitive reserve, you have to think about a disease process that causes cognitive change. So we have Alzheimer's pathology causing cognitive change, and then we have something that we feel disrupts that relationship between the Alzheimer's pathology and cognitive change, in this case education, and here we're able to directly measure all three and show that that's happening. And these kinds of studies have been done over and over and over again. So that's a very quick introduction to the concept of cognitive reserve and the kind of evidence that convinced me that it was really something worth studying. What I spent a lot of time doing, and I'll mention only very briefly here because I've done it for so many years I couldn't ignore it, is trying to understand what I would call the neural implementation of cognitive reserve. Can I use functional imaging to try to understand what the people with higher cognitive reserve are really doing in their brain that allows them to cope with these brain changes better? This is sort of a schematic of my current study, but I'll just walk you through it very quickly. So what we're doing is we have cognitively normal elders and younger people. We measure everything about their brains that we can. All those things I mentioned right at the beginning, the brain volume, cortical thickness, white matter hyperintensity burden, white matter tract integrity. We can also measure how much amyloid or tau they have in their brain. And then we can take a look at how well they do on various cognitive tasks. And even on that level, we can look to see how cognitive reserve variables like education or literacy influence the relationship between these age-related brain changes and cognition. And now what we do is we give them tasks in the scanner, a memory task, a working memory task, or a set switching, an executive function task. And we try to understand by looking at brain changes that the task-related activation, as we call it, the areas that light up when you do these tasks, differences in activation that help us explain what the people with more reserve are doing than the people with less reserve. So here's a little snapshot of one study. So these are, this is not even fMRI yet. This is just showing that levels of amyloid in our population. So we have people 60 to 70 that are very carefully screened to meet strict criteria for intact cognition. And now we have some subset of them that have amyloid in their brain. And what we found is that the people with higher cognitive reserve, higher educational and occupational attainment, had more amyloid in their brain. So again, what it's suggesting to us is that they could get into our study even though they had more amyloid. They could remain cognitively normal even though they had more amyloid. So the people with, if we just look at the people 60 to 70, we find more amyloid in those people with higher education. If we look at people without amyloid and we look at the brain areas that are lighting up while they're doing an executive task, what this graph is showing very simply is that the people with higher reserve are activating the key areas associated with performing that task less. They're using those areas less. And we call that concept efficiency. It's sort of like they don't have to work as hard to do that task. And these concepts like efficiency and capacity of these networks are very often used when trying to understand the neural implementation of cognitive reserve and cognitive aging in general. When we look at the people that have amyloid, we see something very interesting. The people with higher reserve are actually reaching out to sets of areas that are not typically used in order to maintain function, and we call that compensation. These are sort of two concepts that we work through a lot in trying to understand how reserve is implemented. I'm glad to give another 3-hour talk on that another day. But this is, I guess, what we're really interested in. Okay, we have these reserve concepts. How would reserve-based interventions work? So again, we have aging, we have Alzheimer's pathology, we have age-related cognitive changes and Alzheimer's disease. Can we promote cognitive reserve to allow people to deal with those changes better? Can we promote brain reserve or brain maintenance and really prevent these age-related changes from occurring? And that's really, to me, the way to frame these questions about how can we help preserve normal aging or better aging. Now, I'm showing this slide because it's a very, I feel it's a helpful message. What we're dealing with is intervening at a late age. So this is a slide from Marcus Richards, who works with the British birth cohort, where they followed people since birth. And I could frame it this way. You might say, well, Jakob, look, maybe some people are born with a higher IQ, they get better jobs, they get better education, and really everything is predetermined at birth. And so what Marcus had is he had real data on people followed over time. He knew their father's occupation, which was a measure of SES, socioeconomic status. He had an IQ measure at age 8. He had education by age 26. He had occupational attainment at age 43. And they had various measures of cognition at age 53. And what Marcus found is that cognition, education, and occupation each independently contributed to cognition at age 53. So that's a hopeful message to my mind, because it's saying that different life experiences at different stages of life contribute to reserve. It's not that you have a certain amount of reserve and you lose it. There are things you can do along the way that contribute to reserve. And in subsequent studies, he looked at leisure activities later in life, and they also contribute. So what it suggests is that we can do things even late in life to promote reserve. Here's an important study. This is a very nice summary of various risk factors that are potentially reversible that are very strongly associated with Alzheimer's disease prevalence. A lot of them have to do with brain damage and stroke or mini strokes, diabetes, hypertension, midlife obesity, but then we have depression, physical inactivity, smoking, and low education. And each of these is associated with the prevalence of Alzheimer's disease. And what they said is half of the AD cases worldwide are potentially attributable to these factors, so that if we could reduce these risk factors, we could actually reduce the prevalence of Alzheimer's disease. A 10 to 25% reduction in all 7 risk factors could potentially prevent as many as 1.1 to 3 million cases worldwide. So anyway, my point is that there are things that people can do to reduce their risk. Heart healthy, we know about. Here's a very nice study from Nick Skarmeas, who's in Greece now. He used to work with us here at Columbia. He just looked at people who exercised a lot or a little, and people who did the Mediterranean diet, which is a very healthy diet. And the people who exercised and used the Mediterranean diet had a much lower risk of developing Alzheimer's disease than the people who did neither. So we know that physical activity is really important, diet is really important. These are 2 very strong potential interventions. What about cognitive interventions? So cognitive interventions have been really, to my mind, problematic. Usually they show very small effects. A problem in cognitive training is that, let's say you train someone up on memory, that you give them a bunch of memory training. Very often they get better at the test you're training them on, but that it doesn't transfer, as we say, generalize to other cognitive domains, and it's not clear that it generalizes to their real life, to their day-to-day functions. So you don't want someone to get better at a memory test, you want someone to remember to do things throughout the day, and that's hard to do. How sustainable are these interventions, and can we relate them to these interventions to the rate of aging or dementia? So I just wanted to show you 3 big studies with some promising and some not so promising results. What is this ACTIVE study? This was sponsored by the National Institute on Aging, had over close to 3,000 people in it. They had people come to 10 short sessions, training sessions, where they train them on some cognitive skill, and some of them got these booster sessions a while later. They had memory training, reasoning training, speed training, and a control. And at 2 years, this is what they showed, that the people who had memory training 2 years later still did better on memory tests. The people who had reasoning training still did better on reasoning tests. The people who had speed training still did better on the speed tasks, but we didn't see much generalization. Let's say the people who had the memory training did not do better on reasoning or speed. So to me, it's hopeful in that this training, which was quite brief, lasted. It's a little disappointing because it's hard to know its impact on day-to-day life. Now, I have to say they've done longer-term follow-up, and there is some suggestion that even this brief kind of an intervention really helped people many, many years later, and perhaps even with day-to-day function. So it's a kind of study that gives us some lessons and sort of is a strong touchstone for future interventions. Another study that I really like is the Experience Core. It was really originally done in Baltimore area, at Hopkins. It's a totally different approach. It's a community-based program designed to increase cognitive and physical activity in a social real-world setting. So they took people from the inner city and they had them volunteer in the schools. They completed 36 hours of training, and then they worked in the classrooms helping out teachers. And the idea is, here you take people that might not be doing much of anything, and all of a sudden they're physically active, they're socially active, they're cognitively active. The results of the larger scale study are still being cooked, but the preliminary results are supportive of some cognitive benefit and self-perception benefit. I think that this is sort of a very interesting approach because it's real world, it's a plus, these people helped in the schools and all of that. And to me, intuitively, it seems like it should be useful. And then a whole other type of approach is this finger study. The first letter is for Finland. I forget what the rest stands for. But what they did is a very intensive intervention, helping people with nutrition, exercising, cognitive training, monitoring their vascular risk factors over a large period of time. And they report a very small but significant effect on cognition of this intervention. So this is a whole other approach. So what should a large-scale project to enhance cognitive reserve look like? Well, I think, we have to start with healthy elderly people. The intervention, as I'm saying, has to be really thought out. Should it be focused on some domain like the active? Should it be multimodal like the experience core or finger? There's advantage to both. In the end, it's going to be very expensive because we have to follow these people for a long time. And the meaningful outcomes are going to be the rapidity of cognitive or functional decline, or whether people do or do not get demented. But I think that we have the tools and the way of thinking about it that encourages us to look in this direction. This is a sideline. I just wanted to mention, I talk about cognitive reserve, brain maintenance, compensation, efficiency, all these various terms. I'm using them in a way that I've very carefully thought about for a long time. There's other people who've carefully thought about these terms and use them in very different ways, or use the same terms different terms for the same concept. So what the NIA asked, the National Institute on Aging in the United States asked, is to get a process to get people together and reach a consensus on operational definitions for these concepts. And so what we're planning, we're going to have our first workshop in Bethesda in September. Anyone who's interested is welcome to register. You can find it online. And really what we have is a process to try to get people to really make sure that they're thinking about the same thing. And not only in people who do research with people, but people who do research with animals. So we're all talking about the same thing, and we can make more progress. So in conclusion, I hope I've got you to the point where you can agree with me that epidemiologic and imaging evidence supports this concept of reserve. I think it's important to remind you that reserve is malleable and influenced by aspects of experience at every stage of life. We've talked about education, occupation, late life leisure activities, etc. I've spoken about two forms of reserve: brain reserve, which is a passive concept supported by brain maintenance, and cognitive reserve, an active concept. The concept of reserve is applicable to a wide range of conditions that impact on brain functions at all ages. So I was talking about aging and age-related changes and dementia, but the concept has been applied to many other things: multiple sclerosis, HIV, psychiatric changes, etc. Imaging studies can help us clarify the neural implementation of reserve. I hope I didn't zoom through that too fast and confuse you. Accepted, consistent definitions for these concepts will be extremely helpful. And here's sort of the money. Influencing reserve and brain maintenance may delay or reverse the effects of aging or brain pathology. Careful, focused research will help us maximize the chances for successful intervention. And that's the hopeful message behind these concepts. So thank you for your attention, and I think it's time for us to take questions.
Thank you very much, Dr. Stern. It was a brilliant presentation, and we've got over 100 people from different parts of the world on the call, so thank you very much. Perhaps I could kick off with a question from Teresa Ho. And the question was, did you control for income and diet and other lifestyle factors that a better education can afford in the mix of your research, or do you know research that has actually controlled for that?
Yes, so I mean, that's a very important question. When you do these epidemiological, so I showed you a study where we looked at education and we showed a higher incidence of Alzheimer's disease in people with lower education. Then you want to go back and control for as many of these other factors as you can. So in that study, we looked a lot at other health-related matters. We did look, I believe, at income, but subsequently people have tried to make a list of all of these different potential socioeconomic status, health status. There's a whole host of these. And I think part of the issue is that it's really hard to know whether there's something you didn't think of that might be helping with this process. And that's why intervention studies really help you control for that, because you randomize people into conditions.
Well, we've got a couple of more questions. So Lucy Brown would like to know, did you include attitudes and beliefs on aging in your studies?
I have not. I have not, but people have. So yeah, that. So there's this interesting set of personality characteristics that are these positive characteristics. People who think positively about aging, or sort of more look at the good side of things versus the bad side of things. There's certain personality characteristics like that, and people have looked at those and have found them protective as well. So yeah, there's a huge amount of research going on in this area, and that is an interesting focus.
Well, we've got 3 more questions, and I'm going to have a question. So Frederica Conte, I'm interested in the possibility of extending cognitive reserve research to younger populations. For example, there are now studies involving children and adolescents with MS. What lifestyle factors do you think would have the greatest impact at such a young age, given there is not much variability in education or occupation? You're getting some very thorny questions, Yakov.
That's a very good question. So I would, first of all, there are people studying cognitive reserve in MS. Okay. Not in kids, but in more sort of the standard adult level, young adults that develop MS. And a lot of the same things that I've been talking about have been shown in MS. For example, the idea that if we measure the amount of MS lesions, you can measure these white matter lesions or brain volume loss in MS, and these people have shown that these same variables like educational attainment, educational quality, and occupation do make a difference in terms of severity, cognitive severity. But I think that the questioner also raises a very important fact that because a lot of us, on this call are interested in aging, we're thinking about intervening when people are old. But obviously, it would be much better to start this life enrichment early. So what about better quality of school? I mean, not all education is the same. There's huge amounts of differences in quality, et cetera, et cetera.
Yes. Okay. This is a bit of an interesting question. Can you touch briefly on differences between men and women?
That's a very good question. You know something? We have looked at that. It's a question of the time. So that now, just so you know, as a researcher, if you write a grant to the National Institute on Aging, which is where we in the United States get our funding for a lot of our research, at this point you cannot propose a study where you don't explicitly consider sex differences. And in the past, a lot of people have not. So, in these studies of incidents that I'm showing you, and in a lot of our imaging studies, we have not found sex differences. But let's say I alluded to it. There's studies. Exercise is also good for one of the best things. And exercise studies have shown improvement in cognition. A lot of groups have written about it in general, and we just have some data that we're getting ready to publish, suggesting that men and women really benefit differentially from some of these interventions. So it's a very important question.
It is. All right, Sandra McLeod, colleague from Correctional Services in Canada, Ottawa, has asked, even though reserve is malleable across the lifespan, do certain stages of life have more impact than others?
That's an important question too. This concept that I think a lot of people feel that the early IQ and early educational attainment are really quite powerful, as if it's almost a critical period. Yes. But I think that the relative effects of these different variables that we're talking about really differ widely across studies. But I am willing to entertain this idea that there might be certain things that are more important. So early, like there are studies of children where they just look at how many words they're exposed to while they're infants. I think those things might be key.
All right. From Vijay from Mauritius, could you explain the relation between the level of literacy education and the incidences of Alzheimer?
Right. So there's a lot of ways to think about that, but the way that we've thought about it is that because of this literacy and education, people develop more resilient cognitive functioning. What does that mean? People might be faster at how to do things. People might have multiple ways to solve a problem. So that when this brain change starts to occur, these age-related brain changes, the brain itself is more resilient. That's the best I can explain it on 1 foot.
Okay, oh, good. 1 foot's good. Miriam, and I don't know, the question may be a little bit obtuse because of the way it's written, but let's go.
Okay.
How does cognitive reserve can interpret improvement from mild cognitive impairment to normal cognition, or are they associated?
Okay, so in other words, could we intervene in people with mild cognitive impairment in some way? I think that's what we're saying.
Yes. Yes.
Yeah, so there are studies doing that. There are studies of exercise in MCI, in mild cognitive impairment. There are some cognitive stimulation studies in MCI. Can we have someone move from mild cognitive impairment back to normal? Maybe, maybe not. Can we slow the progression going forward? That's something that's more likely.
Yes. All right. So Lacey Brown, she asked a question earlier. She just talked about, she asked about aging beliefs, because some research indicates people with lower income are more likely to internalize negative attitudes and beliefs.
Yeah. I mean, these are things that are being studied. Honestly, it's not my area, but these kinds of beliefs can have some impact.
Yes.
And as I said, these positive personality characteristics, which are trainable, have been shown to be useful.
Right. From Dr. Cynthia Stewart, who is the IFA's main representative in New York at the United Nations, I'm asking, will the NIA support meetings in September for agreed definitions be internationally focused?
Yes. So the NIA, this meeting that I'm talking about, anyone who's listening is very welcome to register and come. It's reserveandresilience.com. And everyone can come. The idea is to bring people who are interested together, and it's going to be a very different kind of a meeting. It's not going to be research presentations like the one I just gave you. It's going to be very much like, here's what I think cognitive reserve is, and here's how I see it in my research. I can show in old people that for a given amount of brain volume loss, people with higher education do better on this task than lower. I call that cognitive reserve. Someone else says, no, I call that resilience. And we're going to talk. So everybody is welcome to join that conversation, and it's really going to be the beginning of a process. And I have to tell you, I follow this. I briefly flashed up a consensus definitions from a work group that I had of 30 people. There's other papers out there with varying definitions, and we have to be able to speak the same language. So please, anyone who wants to come, that's the whole idea of that meeting.
Well, we'll promote that. Look, I've got a couple of questions, and then we're going to close, Yakov. So one of the questions is, will meditation help in increasing cognitive reserve?
Good question. Meditation is one of those things that has been shown to be useful for cognition. There have been meditation studies done in normal aging to improve cognition, either just straight out meditation or things like Tai Chi, which encourage that kind of mindfulness meditation. So will it increase reserve? It's hard to know. I think yes. I think that someone who's a meditator, on the face of it, should do better in the aging process.
Okay. Look, there are some other questions, but Yakov, we're going to put them into an Excel spreadsheet and talk you through them so that we can get back to the attendees, if that's okay.
Absolutely.
So I want to thank you, but I also want to ask whether you would be willing to come back later in the year and talk to us a little bit more about the meeting that you've had in September.
I would be very glad to do that. Thanks for the invitation.
Well, IFA will certainly be promoting, reserveandresilience.com, and to make sure that you have, maximum attendance. Do you know, we had about 100 people attend this conference, and just only in the last couple of minutes have they started to drop off. And that says to me that this presentation was well worth being part of, and we thank you enormously for your involvement, and the way that you presented it enabled everybody to be part of it. So we thank you very much.
Well, it was my pleasure.
Good. And just in closing, I just want to thank all the people at the IFA, those that attended this important presentation. Some of the video, the presentation and the audio wasn't clear to some people, so that will be made available to all those attending on the call. And also, as well, we encourage you to be part of the Cognitive Reserve Summit, which is in October in Copenhagen. You'll all get a link to that. And the only reason that Dr. Stern isn't able to come is his son is getting married. So that's bad luck, but we'll have you next time. In closing, I just want to thank Anna Sangster for being on the other end of this webinar and helping to make it happen. So thanks, Dr. Stern, and once again, a remarkable presentation, very informative for all of us. Thank you.
Okay, thanks and bye.